Okay, 6-4, elimination using multiplication. So, the last lesson we learned how to solve systems of equations with addition and subtraction. Today we're going to do the same principle, but we're going to be multiplying our parts of our terms of our equation to get them to work for elimination. So the key concepts here are you're going to do the same thing. You're going to look at your equation. If you can't add or subtract, then you look and see, well, could I multiply? Can I multiply at least one part of the equation by a number to get two equations that have opposite terms? All right? Then we, of course, just step 2 like it was before. You add the equations, eliminate one variable, solve the equation, and then solve, right? And then step 3, you'll substitute the value in for the variable that you solve for and find the value of the other variable. So let's take a look at one of these types of problems. All right, 5x plus 6y equals -8. And 2x plus 3y equals -5. Okay, so you can see we have nothing we can just eliminate by adding or subtracting. However, of course, I noticed that 6 and 3, there is something I could multiply by to change my 3y to 6y, and of course, that is 2. So what's going to happen is I'm going to multiply everything by 2. But if I multiply by a positive 2, I would have a positive 6y right here, wouldn't I? And I really need a negative 6y. So what could I multiply by? I can multiply by -2, and I'll multiply both sides of the equation by -2. And that will give me -4x minus 6y equals a positive 10. Now that I can add my other equation, 5x plus 6y equals -8. Add those together, I see that these cancel out, and I get -4x plus 5x leaves me x equals 10 minus 8 is 2. So x is 2, right? X and y, right? So my x is 2. Now I have to find out what my y is. So I'll take x and substitute it into one of the original equations. So 5x, so that's 5 times 2, plus 6y equals -8. So 10 plus 6y equals -8. I get 6y. I won't skip that step. I minus 10 on both sides, and I get 6y equals -18. Divide both sides by 6, and I see that y equals -3. So my solution is 2, -3. Easy enough? Good. All right, let's see if I can move this guy. I don't know if I can. Okay, there he goes. All right, sometimes you have to multiply each equation by a different number in order to solve the system of equations. All right? Sometimes you're going to have to multiply one of them by one number and one of them by the other. Well, if we look at this equation, 4x plus 2y equals 8 and 3x plus 3y equals 9, I realize that 4 and 3 both have a 12 in common, right? So we could multiply this one by 3, and we could multiply this one by -4, okay? And let's see what we get. 4x times 3 is 12x, and 3 times 2 plus 6y, and 3 times 8 equals 24. And now I multiply the second equation by -4, and 3x times -4 is, of course, -12x. and negative 4 times 3y is minus 12y, and negative 4 times 9 is equal to negative 36. I'm going to add these two equations together, and I get 6, those two cancel out, I get 6y minus 12y, I get a negative 6y equals 24 minus 36 is negative 12. Divide both sides by negative 6, and I see that y equals a positive 2. Okay, so now I know I have to find I know my y, it's 2, and I have to find my x. So I'll take, I'm going to take this, a 3x plus 3y equals 9, and substitute in 2. So 3x plus 3 times 2 equals 9. So 3x plus 6 equals 9, minus 6 minus 6, and I get 3x equals 3, so x equals 1. And there's my solution. Okay, guys? Not so bad. If you do have questions, though, we'll do a couple more problems in the morning. Try the guided practice. See how you do. And maybe we'll get somebody to put these up on the board and explain it to us tomorrow. Oh, here we have a little math history link for those of you who are interested. We have Leonardo Pisano, who is better known as by his nickname Fibonacci. You've heard of this Fibonacci sequence. You've probably heard about him in it was made famous too in a movie. You know, it wasn't Angels and Demons, whatever that other movie is. You guys know, with Tom Hanks. Anyway, that one. And, okay, we'll keep moving. Let's make this short, right? Okay, here we have our real-life example. A personal aircraft traveling with the winds flies 520 miles in 4 hours. On a return trip, the airplane takes 5 hours to travel the same distance. So on the way there, it's traveling with the wind. On the return flight, it's not going to have the wind, right? So you're, part of this problem cut out. So what they want you to do is to find the airplane, find the speed of the airplane when the wind is still. Let's see if I can add that in here. Find the, oops, just kidding. Oh, well, take my word for it. Okay, I'm not going to add it in right now because that'll just take too much time, and we don't want any more time taken up, right, guys? Okay, so find the speed of the airplane when the air is still. So what we can do, we can say, okay, A is the rate of speed of the airplane in still air. And B will be the rate of the wind, right? And when he's with the wind, you can see they've made up this little chart. And this chart's helpful. It makes you really think about what everything is. You know how I always talk about my little grocery list that I like to make, and what do I know, what don't I know? Okay, so we know distance equals rate times time, don't we? We've had that formula before. D equals rate times time, okay? So with the wind, we have the speed of the plane, A, right, plus the wind. And it took, how long? It took 4 hours. And the distance was 520 miles. So we can write that as an equation, rate times time equals distance. The distance is 520. And we multiply the rate, which is the airplane speed plus the wind speed times 4 hours, all right? And then we'll look at the next one. Let's write our other equation against the wind. So we'll have the rate of speed of the airplane, but we're going to have to subtract the wind speed because it's working against us, and that takes us 5 hours to go the same distance. So that equation will be A minus W times 5 equals 520. All right? So our two equations are this. 4a plus 4w equals 520, and 5a and 5a minus 5W equals 520. So do you see we've just distributed these two things when we wrote these two equations, right guys? Everybody follow that? Okay, now what can we do to solve this? Well, it looks to me like we're going to have to multiply. And we already have opposite signs right here. See that? So we aren't going to have to multiply. We can multiply by a positive number. We won't have to multiply by a negative number. But let's multiply this one times 5 and this one times 4. Okay? Everybody with me so far? So we'll end up with 20A plus 20W equals 520 times 5 is 260. Excuse me, 2600. And then we have the next one, we'll multiply by 4 and we'll get 20A minus 20W equals, and 520 times 4 is 2080. Yes, 2080. 2080. These two cancel out. We get 40A equals 4680. Divide both sides by 40. And we find out the speed of the airplane is 117. If I were writing a sentence, I'd say the speed of the airplane is 117 miles per hour, right? Okay, so if A is 117, we can go up to our original equation, 4A plus 4W equals 520, and we could also find out the wind speed. But actually, we didn't need the wind speed. All we needed was this for an answer, now that I think about it. So you won't need to do that. Okay. There's one more, here's a practice problem for you. A canoeist is traveling 4 miles downstream in 1 hour. The return trip takes the canoeist 1.5 hours. Find the rate of the boat in still water. Okay, good luck with that, guys. And we'll give a bonus point to whoever, on the homework, to whoever wants to put this one on the board and explain it.